Today I'm going to do a science lesson on natural selection. Natural selection is the way a living thing is best suited to an environment for survival. When a living thing survives in an environment, usually they reproduce and pass their traits or characteristics off to their offspring. There's a man named Darwin, Charles Darwin, who came up with this theory of natural selection. And he had 4 main points to his theory. The first one, overproduction. The second one, competition. The third one, variation. And the last one, survival of the fittest.
Go.
Survival of the fittest is the last one. Quickly, let's talk about what each means. Overproduction happens when a living thing gives birth to many babies. Not all of those babies can survive because there are not enough resources for them to survive. That's overproduction. Our next main point for Darwin's theory of natural selection is competition. You all know what competition means. We compete when we play video games. We compete in different sports. But as far as natural selection is concerned, competition happens between offspring, or also known as the babies. They competed for resources so they could survive in the environment. Only those babies that can get the resources will survive and reproduce. The rest will unfortunately die out and not reproduce.
Thanks.
The third main point to Darwin's theory of natural selection is variations. Variations simply mean the differences among the members of a species or a group of living things. Some members have special features to help them to adapt or to fit into an environment so that they can survive. And the last main point of Darwin's theory of natural selection. When there's variations or differences in a particular group and they all struggle to survive in their environment, it's known as survival of the fittest. These living things that are able to survive or have the best adaptation qualities are able to survive and reproduce. And the organisms or the living things that do not have these variations may not survive in an environment.
Thanks.
So, as far as natural selection is concerned, it is the best way that a living thing adapts to this environment. Their goal is to be the survival of the fittest. So what we're going to do now, we're going to do a cool activity. We are going to model natural selection. And our first step to model natural selection is we're going to create a chart. And we're going to title it Modeling Natural Selection. We're going to provide 3 groups. In the first column, we are going to name it generations. There are going to be 3 generations. So 1, 2, and 3. Generations of what, you might ask? You'll soon discover that we will be in a forest and there will be green butterflies and then there will be red butterflies. So we're going to label green squares, which will represent the green butterflies in the environment, and we will label this column red squares. And the red squares will represent the red butterflies. In our forest for the first generation, we have 20 green butterflies, which will be represented as green squares for this project. And we will have 20 red squares, just to keep the playing field even. And the red squares will represent the red butterflies. Here's our forest. Pretty forest, right? You can imagine trees and everything are there in the forest. I'm not really good at drawing. So imagine this is a plain field of grass. And our first generation of butterflies are all over the land. Our goal is to model a predator. And we are going to play a quick game where we pick up as many squares as possible, one at a time, and record it for 15 seconds. After we get an amount of how much butterflies we took out of the environment, we will count the squares that are remaining.
Go.
So we have 15 seconds to pick up as many squares as possible. Are you ready? And begin. Okay. Now, the poor little butterflies that were taken out of the land are no longer there. They were not able to survive in that environment. So we are going to record how many red squares are left. And after we record how many red squares are left, we are going to multiply that by 2 because we know that in the second generation, they were able to reproduce. And then we're going to do the same with the green squares to see how many green squares were remaining. So let's start with the red ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 red squares remaining. And we're just going to multiply that by 2. And that gives us 22. So let's add 11 more red squares in this generation. And also, please note that you recorded on here. So now in the second generation, we have 22 red squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's do the same with the green squares. 1, it's kind of hard to do, but it can be done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 green squares. And we multiply that by 2. (32) green squares. So now that we have 16 here, we add 16 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 32 green squares, and we record that here to represent our generation number 2. And now we're going to repeat the process. We're going to put all of these offspring, or our generation 2, in our forest again. And we're going to time ourselves.
Action.
So similar to the first time when we modeled ourselves as predators, we're going to do the same thing again. And we are allowed only 15 seconds to hunt the beautiful butterflies in the forest. Ready? Begin. One flew away. Okay. Time's up. Now we have to do the same step that we did before, where we counted each group of butterflies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 red squares that represent the red butterflies. And we multiply that by 2. That gives us 24. And we do the same thing with the green butterflies. It's a lot of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28 green squares. That represents 28 butterflies. Times 2. 56. Woo! So we have to record that number here. So in the third generation, there were 56 green squares, or 56 butterflies. That's what we call them. And 24 red squares. What do you notice? Which color butterfly can be seen most by the predators? If you guess red, yes. Because in a green forest, the green butterflies were able to camouflage or to adapt and change the way they look to the environment so they could fit in and be protected from the enemies. According to natural selection, the helpful traits allow for the organisms or living things to survive in an environment. And that's how we modeled natural selection. You could do this game any way. You could get a big green fabric and put it on the floor, and you could race to the fabric and let the squares be the same size. So it could be a little bit harder, you know? It would be a great activity for you and your family to even do at home. I hope you enjoyed. To end this activity, I want you to visit Amazon.com. If you have a Kindle or a tablet or even your phone, you could download Pepper's Special Wings. It is a story about natural selection. Pepper's Special Wings show how Charles Darwin's theory of natural selection works. There's easy words, colorful pictures that you can use to understand. And it's based on actual scientific case studies. Also, and as an extension activity with this lesson, you can help identify Peppers shows who struggles, sense of self-esteem, self-image, bullying, and being teased about recovering childhood themes. It is truly an amazing story. And not only will you enjoy reading this book, you will also enjoy learning more about natural selection.